Welcome to Craft Guru Education. Learn chemistry in 3 hours. This is video number 4. Let's learn how to write chemical equation. In video 3, we learn how to write ionic compound. Perhaps I want to explain a bit more about ionic compound. Let me share my screen. This is the list I share in video 3. We have positive ions and negative ion. Pay attention to the negative ion. When fluorine becomes negative ion, the name change to fluoride. The spelling change. It's like when female married to male, they have to change their surname. So for negative ion, the name will change. Instead of called fluorine, it is now called fluoride ion, IDE. Same thing as chloride, bromide, iodide. If they are just molecule, it is called chlorine, bromine, iodine. And let's look at nitrate. If you see the ATE at the back, it is NO3. If ITE, it becomes 1 oxygen lesser, NO2. Sulfate, SO4. Sulfide, ITE, SO3. Just need to get used to all these names, and for negative ion, you should be able to write the ionic compound and call its name easily. Some people send me questions, ask if I can give more example on how to write chemical equation. So in this video, there will be 2 parts. Part 1, recap on how to write chemical equation and some additional information. And part 2, we will talk about mole, the calculation of mole. Let me share another screen, handout number 2. Okay, same information. If you would like to have this handout, do fill up the Google form and we shall email to you as soon as possible. Okay, this is handout number 2, more about chemical equation. When metal want to become stable, it will have reaction with non-metal. But is chemical equation just between metal and non-metal? Not necessary. It can be between metal and ionic compound, or non-metal and ionic compound, or between ionic compound and ionic compound. The basic chemical reaction is between metal and non-metal. We have learned this in video 3. Here, I would like to talk about metal and ionic compound. If you are using my handout, you can try to write the balanced chemical equation for calcium bromine. Notice that after the reaction, bromine's name changed to bromide, so it is calcium bromide. Alright, let's look at metal and ionic compound. Recall, ionic compound is between metal and non-metal. So we have zinc, nitrate. It is metal and non-metal. In this example, whether the chemical reaction will happen or not depends on who is more handsome. Now metal want to react with this ionic compound. Again, using the love relationship example, this is a married couple. And this guy trying to come and break the two of them. Will he be successful? Depends on whether he is more handsome or not. So talk about who is more handsome, you need to memorize the reactivity list. The reactivity list I have summarized in this handout for you. If you scroll down, you can see the reactivity list. Perhaps I should change this to reactivity list. I put handsome list is more of for your easy understanding, but in chemistry, it shouldn't call like this. And I have put in the acronym here for your easy memorization. The most reactive element or reactive metal is potassium. He is at the top, followed by sodium. Of course, beryllium is not in the syllabus, that's why I put a cross there, but if you are curious, beryllium is after sodium. Sorry, it's not beryllium, it's barium. So barium is after sodium. Potassium, sodium, barium, calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, mercury, argentum, platinum, aurum. Aurum is gold. How to remember this list? You can think of this acronym. King Narnia can make aluminium zebra fly, so pony can hide around Perth, Australia. If you can remember this, then you can remember the reactivity list. Potassium is the most reactive metal. In the layman term, he is more handsome than sodium. Let's check. Just now, aluminium and zinc. Who is more handsome here? Or who is more reactive? Now, aluminium is more reactive than zinc. Go back to just now the chemical reaction. Aluminium is more handsome than zinc. So aluminium is more handsome than zinc. He will kick zinc out. He will kick zinc out, replace zinc and become aluminium nitrate, and zinc become alone. So this is another chemical reaction you need to understand. How do we write the chemical equation? Aluminium is metal, therefore it should be a single atom, Al. Zinc nitrate is ionic compound. You can write their charge temporally. Zinc is 2+, nitrate is NO3, 1 negative. Using the shortcut, just cross the number here, meaning we need to have 2 nitrate, 1 zinc. We write like this, Zn bracket NO3, close the bracket, the 2 put outside. Why we use bracket? Because this is N capital letter and O capital letter. We have 2 different elements here. It's not like NO small o like this. So if NO small o, you don't need to use bracket and put the 2. But this is different, that's why we need to put a bracket and put 2 there. Now we managed to write the ionic compound, the formula for zinc nitrate. We just put it back to the equation here, plus zinc nitrate, close the bracket 2, and become aluminium nitrate. So how to write aluminium nitrate? You can write their ionic compound here temporarily. Aluminium is Al3 positive, NO3 is 1 negative. Cross the number, you get 1 aluminium and 3 nitrate. That's right, it's Al bracket N O3, close it, put a 3 here, plus zinc. Zinc is metal, it should be single atom, so just write Zn will do. The last video we talked about the steps of how to write chemical equation, write the correct formula for both metal or non-metal. In this case, it's metal and ionic compound. After you have written all the formula correctly for each element or compound, then only we balance the equation. Normally, we start from negative ion. Let's see, NO3 in this example has 3. Or you can check the lowest common factor for 2 and 3 is 6. So we put a 2 in front. 2 times 3 is 6. So we have 6 NO3 on the right side. And here I add a 2 in front. 2 times, I add it should be 3. Let me delete and put a 3 here. So 3 times 2 is 6. So on the left side, we have 6 NO3. Okay, let's check on the right side, 2 aluminium. We add a 2 here. And on the left side, we have 3 zinc. So we add a 3 here. Okay, so the correct chemical equation for aluminium and react with zinc nitrate is 2Al plus 3Zn bracket NO3, close it 2, you get 2Al NO3 3 plus 3Zn. Do you have any question? Easy to write this chemical equation once you know how to write the ionic compound. You can pause the video and try to practice this equation before we move on to the next example. Okay, the next example is between non-metal and ionic compound. So for non-metal, I use the analogy as female. Who is prettier? If that non-metal is prettier, he can kick the wife out. Let's see if chlorine is prettier than bromine. Check the list at the bottom here. Fluorine is the most reactive non-metal, followed by chlorine, bromine, iodine, which means now chlorine is prettier than bromine. Therefore, this chemical reaction can take place. If this chemical reaction cannot take place, you don't have to write the chemical equation. Just say it will not take place. All right, so sodium is 1 positive. Bromide is 1 negative. Cross the number, we need 1 sodium, 1 bromide. The ionic compound is NaBr. React with chlorine. Remember, chlorine is non-metal, it has to be in molecule form. So Cl2 become, okay, here we have to check the ion again. Do not just combine Na and Cl2 like this. Sodium is Na positive. Chlorine is Cl minus. Same thing, we need 1 sodium, 1 Cl. And bromine now become alone. It turned into molecule back. So we put Br2, its molecule. Time to balance the equation. On the right side, we have 2Br. Here we put a 2 in front, and it affects sodium. 2 sodium on the left, put 2 in front of sodium chloride on the right, and that affects chlorine. So 2 chlorine. Let's check on the left, it's 2 chlorine, balance already. So we stop like this, and it is already a balanced equation. To recap, it is 2 sodium bromide react with 1 chlorine molecule to have 2 sodium chloride. Erase this. Two sodium chloride and 1 bromine molecule. This is how we write chemical equation. Last but not least, the last type of chemical reaction is between ionic compound and ionic compound. For ionic compound and ionic compound, we just think they exchange partner. They exchange the non-metal. This one come over here, this one come over here. Of course, later on, there are some other chemical equation like between acid and base, acid and alkaline, that we will cover in acid and base lesson. But here, overall, we have these 4 types of chemical reaction. The last one is between ionic compound and ionic compound. They exchange partner. Ammonium sulfate react with iron 3 nitrate. We get ammonium nitrate and iron 3 sulfate. Step by step, we check the ion, positive ion and negative ion first to figure out how to write the formula for that ionic compound. Ammonium, we know is NH4, 1 positive. Sulfate, SO4, 2 negative. If you look at the formula, NH4 means we have nitrogen, hydrogen here, 2 elements. Sulfate, same thing, sulfur and oxygen, 2 elements. We also have iron 3, that means it is 3 positive. Now let's write the formula for ammonium sulfate. Ammonium is 1, sulfate is 2, so we need 2 ammonium, 1 sulfate. 2 ammonium, put in the bracket, NH4, close the bracket, put the 2 here. Sulfate, we only need 1, so SO4. Plus iron 3, 3 positive, nitrate is NO3 negative. Cross the charge, that means we need 1 iron and 3 nitrate. NO3, close the bracket, put a 3 here to become ammonium nitrate. Ammonium is 1 positive, nitrate is 1 negative, so just need 1 each will do. NH4, we only need 1, NO3, we only need 1. And then iron 3 sulfate, cross the number, 3 go to the sulfate, 2 go to the iron, so the formula become, I need to erase this here, plus iron, we need 2, sulfate, put a bracket, we need 3. This is the chemical equation, but we haven't balanced it. Time to balance the 2. The difficult part is NO3, we have 3 on the left side, so we balance the NO3 on the right side. If we put a 3 here, it will affect the ammonium. Ammonium has 3 on the right, but 2 on the left only. So how can we balance this? Let's think of how to balance this equation, pause the video and you can play it again so that we can check the answer whether your thinking is the same as what I'm thinking. Did you manage to figure out how to balance this equation? It's a bit difficult for this example. Let's think of making nitrate become 1. I will put 1 over 3 here because 1 over 3 times 3 nitrate cancel off. That means on the left side we have 1 NO3 now. On the right side we have 1 NO3 balance. But on the left side we have 1 over 3 Fe. On the right side we have 2 Fe. How do we make it become 1/3 of Fe? We times 1 over 6. 1 over 6 times 2, we get 1 over 3. Then it affects sulfate. Sulfate, we have 3 here. But times the 1 over 6 in front, 1 over 6 times 3, we have half. So we add half in front here. We have half SO4. On the right side also half SO4. So adding half on the left will affect ammonium. So half ammonium times 2, we have 1 ammonium. So on the left side, in the end, we have 1 ammonium. Let's check. On the right side, we also have 1 ammonium. This way, we balance the equation. Of course, we cannot leave the equation in fraction like this. How can we make it a whole number? Let's see, we have 1 over 2, 1 over 3, and 1 over 6. The highest number we can use to make them a common one is 6. So we will times every element with 6. So here, 1 over 2 times 6, we have 3. Let me write smaller so that we have enough space to write the whole equation. 1 over 2 times 6 is 3. NH4, close it. Okay, 1 over 3 times 6, we have 2. Fe. And then here we have 6. 6 times 1 is 6. Finally, 1 over 6 times 6 is 1. So we leave it as Fe2, SO4, 3. Okay, let's check. On the right side, we have 3 SO4. Here, 3 SO4. Then it affects the ammonium. We have 3 times 2, 6 ammonium. Here we have 6 ammonium. Then this 6 affect the nitrate. We have 6 nitrate on the right side. So 3 times 2 is 6 nitrate. Last but not least, it affects the iron. 2 iron. Here got 2 iron. So this is the balance equation for ammonium sulfate react with iron 3 nitrate. I hope now you get the whole picture how to write chemical equations. Through video, it's difficult to practice writing chemical equation. Get the handout from me, practice, and we can have a discussion group. Video, I explain the fundamental concepts, and it is up to you. You need to put in effort to practice at home. The next part of this video, we talk a little bit about relative atomic mass first. Video 5, we will look at the proper calculation of mole from chemical equation. For relative atomic mass, recall back in lesson 1, we learned about neutron number, or we learned about the neutron and proton in the nucleus, and then we have the nuclear number. We will need to use this for this part of the learning. Nuclear number, recall, nuclear number is the number of neutron plus proton. In video 1, we talked about atomic structure. I didn't elaborate more about neutron because we want to straight away go into the core of chemistry, how chemical reaction happen. So now it's time to explain more about neutron. Neutron relative mass is, let's say, 1 gram. Proton is also 1 gram. Electron is too light, it's like 0.0000 something gram. So we ignore the mass of electron. For the mass of an atom, we only use neutron plus proton to calculate it. So neutron and proton together we call nucleon number. This nucleon number is stated in the periodic table. Here I attach one periodic table for your easy understanding. You can take a look here. This periodic table don't have the nucleon number. Normally the nucleon number is written at the bottom here. Let me change the periodic table so that you can understand how to calculate the mass of an atom. Alright, I have updated the periodic table. Let me zoom in for your easy view. Here. You can see from the screen on top is relative atomic mass. This shows the number of neutron plus proton. The atomic symbol, this is the proton number. For hydrogen, the relative atomic mass, or in short we call RAM. It's not the computer memory, it's the relative atomic mass. That means the mass of this atom. For hydrogen is 1, the proton number is also 1, meaning hydrogen has no neutron. Helium, proton number 2, RAM is 4, that means he has 2 neutron. Lithium, proton number 3, nucleon number is 7, that means it has 4 neutron, and so on. This number on top represents the mass of that atom. If I ask you what is the mass of chlorine, 35.5. What is the mass of calcium, 40. What is the mass of calcium chloride? We check calcium is 40 plus chlorine, 1 atom is 35.5. We have 2 here, so 2 times 35.5 is 71. 40 plus 71 is 111. So the mass of calcium chloride is 111 gram. This is how we calculate the relative formula mass. Here, because it is a compound, we call relative formula mass. If it is atom, then we call relative atomic mass. But in overall, perhaps in my future video, I will habitually use RAM. So understood means the mass of the atom, or the mass of the molecule, or the mass of the compound. Of course, in proper chemistry term, we should use the correct one like RFM, RMM, or RAM. So with that, let's conclude today's video. We will look at how to do all this calculation in video 5. It's really easy to understand chemistry once you know the electron configuration, you know how to write ion. Knowing how to write ion, you know how to write the formula, and then you know how to write chemical equation. If you like this video, please share and subscribe. See you in video 5.